This is a conversation with Jason Richards. Jason is the CEO of DaxBot, which makes a charismatic robot for food delivery. We talk about DaxBot's delivery robot, their crowdfunding campaign, DaxBot's revenue model, how Jason works with lawmakers to have robots on the sidewalks, and Jason teases their real-time operating system, DaxOS. This is the Sense Think Act podcast, and thank you to our founding sponsor, Open Robotics. Now, here's my conversation with Jason Richards. Would you introduce yourself?
Sure, you bet. My name is Jason Richards, and I am the CEO of DaxBot.
Would you tell me a bit about DaxBot?
Sure, yeah. So DaxBot is a robotics company that started out at a research and development lab about 2015. The founder had started a couple other companies, pretty successful guy, and decided that wanted to create a research and development lab to, what is the next wave of technology that we can get in front of, And so in 2015, one of the thoughts was, okay, well, we need robots to be able to do things. And there's plenty of robots in the, in the workforce, more in factories and things like that. Mm-hmm. But how do we bridge the gap into the next generation of robotics where you have robots that are on the streets, similar to, iRobot before the robots go bad kind of thing.
Like the movie.
Being able to have robots. Yeah, like the movie.
Not the company that makes the vacuum.
Yeah. Not that company. No. Yeah, the movie, right? So you can tell a robot, hey, pick up that and go watch that window. And robots are smart enough to go and do it in human space. So that was the idea. And looking at what things could be most helpful out of the chute is the delivery seemed like a natural first thing that a robot could do that would be pretty simple, simple task that would be helpful to humans. Mm-hmm. So that's where the idea came from. And so as of recently, we just got through restructuring companies. Now we're DaxBot Inc. And now we're able to go after and commercialize and have robots now being deployed to different states around the country.
What were you before?
So before it's Nova Dynamics. So Nova Dynamics was the research and development incubator. And they've got several projects. Dax, as the robot, was kind of the big one. And so with that platform, we knew that at some point it has to move out of the R&D lab and into its own entity that can be commercialized and become something.
Gotcha.
Right? So that was the next step. So as of last year, when all the research and development last year, when COVID hit, it was a great opportunity to start getting robots out in the field in our local hometown because restaurants people aren't coming to. Mm-hmm. Restaurants are closing their doors, but people aren't wanting to see people. So it seemed like a great space, and it was, for that beta test, being able to take robots that we have, go to the restaurants, pick up food, and then take it to people's houses, all without seeing a human was, it really highlighted the need for this type of technology. And it was well received, and it was a great beta test for us. So January of this year, realizing, okay, we've got a product that is ready to go.
Awesome.
So commercialize, and here we go.
Hell yeah. Tell me, can you describe what Dax looks like?
Yeah, so Dax is
and we see the one
a robot
you,
that's about
right?
Yeah. If you're watching the video, you can see the one behind, and it's about 3 foot tall and white and black, kind of a reverse tuxedo type situation.
Oh yeah.
And so you see Dax has got a fully articulated neck, so that he's able to look all around and look up and down. Also has LED panel eyes, so the eyes are able to be expressive. Whether it is being able to be hearts or I love you, going to sleep, blinking, so that it has some sort of emotional response from another human. Mm-hmm. So that is, and then the cargo. That's the thing that everybody asks. Well, if it's a delivery robot, where is the cargo bay? And it's actually inside the stomach. Mm-hmm. So what you would think of the stomach of this little creature. For people that haven't seen Dax before, I'd encourage you to go. You can check out DaxBot.com. You can see pictures of him and that kind of thing. But inside the drawer, which is where his stomach is where the payload goes. And then inside that is a heating element. We've got a design for a refrigerator so that we can do
that's cool.
Pharmaceutical delivery. Yeah, things that need it, which is pretty. That was a pretty astounding thing from the engineer's perspective to be able to build a refrigerator inside the robot. Obviously, it takes up a lot of space with a compressor and heat exchange, especially in that tight of an area. But fascinating, and we did a lot of cool testing with that one. But so that is Dax.
Gotcha. And so to me, Dax, I was going to say refrigerator, like a little like college dorm freezer kind of thing.
Right.
Dax kind of looks like one of those, and then it has this articulated kind of like hexagonal head that has the LED lights on it. And that head is on a neck that seems to have a few degrees of freedom, which I'm sure we'll talk more about that later. And we can't see it in the video now because of how the camera is positioned, but Dax is on tank treads, right?
Yep.
Gotcha.
Correct.
And to me, Dax looks a lot like Wall-E without arms. And like you say, like the belly is where you store the payload, so whatever you're delivering. Like in Wall-E, Wall-E was designed to have that trash compactor there in its belly, so it seems kind of similar to me.
Right.
And the tank treads. And these kinds of things.
Yeah, we joke about the fact that Dax kind of looks like Wall-E and Eve had a baby, and that baby was Dax.
That is right, because of the coloring. And the sleek design.
Color in the scheme.
Yep.
Yeah, exactly. So.
Okay. Tell me a bit about the neck, or the head, I guess.
Yeah. So the biggest piece that we wanted to solve was, the human-robot interaction piece. There are other delivery robots. There's a lot of people that will ask about that. Why essentially another delivery robot? And it's kind of funny because, Dax was built. People are familiar with Starship. Dax and Starship started almost the exact same time.
I'm not familiar with Starship.
As far as like,
what is Starship?
Oh yeah, so Starship is a delivery robot on some college campuses. And if you look up delivery robots, if you just Google it, you'll find KiwiBot and Starship, and there's some others. And essentially the same. The design is exactly the same. It looks essentially like a cooler with a couple wheels on it, and so it has a payload, and it's useful in some applications. But with the neck and the eyes, it was more of, how do you create something that is going to be accepted in human pedestrian spaces? So that's where the idea of, an articulating neck, head, not putting sensors all over the place. And the founder, of DaxBot really wanted to make sure that it wasn't creepy. There's plenty of really cool, like, mechanically amazing feats that people are coming up with, as far as like mechanics of robots, bipeds, those types of things. But if, for example, you just saw, two robotic legs running at you down the street, you'd think that Armageddon was happening. I mean, that would be a creepy thing. So wanting to make something that would be accepted in human space. So there was a lot of work that went into that, of how do we make a robot that people want to have around. So delivery robots, most of them have that design of a cooler on wheels about 2 feet off the ground. And it becomes an annoyance for a lot of people because it's in the way. Similarly, people don't even want bicycles on sidewalks, right? And it's a human on that bicycle, but it's annoying in the pedestrian space. And so they make bicycles.
Is that because of the, I don't know if it's quite the same thing. I get that they're also annoying, but perhaps it's like they go fast and there's the potential to like get hit by a bicyclist or something like this, or them to come out of nowhere. Whereas I don't know that a small tub robot would be quite the same thing. Or what do you think?
No. Yeah, the biggest piece had to do with visibility, is not being able to see it. If it's at knee height, it's different than if it's at waist height or shoulder height.
Gotcha. So it's like a mobile piece of furniture to trip over if it's short, and that could be irritating. Okay.
Yeah, and same way. I mean, people don't like skateboarders on sidewalks.
Yeah, again, moving fast though.
Remote controlled cars.
Often.
Yeah, I mean, some of it could be moving fast, and it's in a way it becomes a tripping hazard, that kind of thing. And so the interesting thing with Dax is that with all the testing we've done on the HRI side of it is, especially kids love Dax. It's about the same height, and so they can give it a hug, and it's looking them like almost eye to eye.
That's very cute.
And with the neck itself, and the reason that we didn't want it creepy with sensors all over the place, people ask, well, it has 360-degree camera in it, for example. It's kind of an assumption a lot of engineers have. It's like, no, there's not 360-degree cameras in it. And people always want to know why. It's like, well, you don't have 360-degree cameras in you. You can kind of hear that there's stuff behind you.
Mm-hmm.
And so you can, you have some sense and awareness of what's around you. But you're not a spider, right? You don't have this spidey sense where you know that something's behind you. So in the same way, that's where the articulating neck came from. You could have something that knows everything around it in a 360-degree view, or you have something that actually is more like, more like a dog or a human, where you actually have to turn your neck around to see what is actually going on behind you. And so even those pieces, it gives it a feeling that it is actually alive instead of just being a machine, which
not?
It actually is just a machine.
So, I mean, I'm thinking of this saying where it's like airplanes don't flap their wings kind of thing. So, I mean, we can draw some inspiration from biology, but where do we end drawing inspiration from biology?
Yeah, absolutely.
And I wonder, I would think it would be possible to use cleverly hidden sensors and to have the articulating neck, but have the articulating neck not necessarily tied to a vision system. Why limit it to having the vision system on the articulating neck instead of just having hidden sensors and this kind of thing?
Yeah, that's a good question. I don't know the founder when he went through all of this. There was a lot of reasoning and things like that. And again, making it more a phrase that we use around here is canamorphic. It's not
canamorphic.
It's not an canamorphic. I don't know who
is that like
coined
kind
the
of
phrase,
anthropomorphic or
more like a dog. Yeah, yeah. It seems more like it's a pet than it is a machine. And so
anamorphic. Okay, so it's like anthropomorphic.
Yeah, anamorphic.
So when we assume, but for things like dogs or whatever it might be. Okay, so it's a creature and has some sort of intent when it moves around the world or whatever it might be.
Right. Yeah, exactly. And so one of the things, for example, is I believe one of the stories I heard is that if Dax, if the robot goes into a situation and needs to go backwards, we as humans don't walk backwards. Right? We don't just like walk backwards into a space. Yeah. We usually will turn and say, "Oh, here's where we're going to go," and then if we need to have some field of vision in front of us, we'll be looking back and forth. So in the same way, wanting to train the robot, right? Train the neural net so that it's not just doing things automatically, so it actually is showing intent. That here's where I'm going. One of the things that we've heard, we actually we live close to a university, Oregon State University. And Starship, one of those competitors, is up there. And I haven't talked to anybody around that really likes them on campus. And the reason for that is because it has to do with intent. So the device will drive up to a street corner and then stop. And then all the other traffic, the cars,
they're like, what is it doing?
What do I do? Yeah, is it going to cross? Am I going to cross? There's no
clear signaling.
There's no law about right of way. Yeah, exactly. So since there's no signaling, there's no idea, are you going to go? Am I going to go? And so it's, some of these devices have been hit. One got hit by a train. One's, it's been hit by a truck. One's going into a truck. Yeah. And so it's, and it has plenty of sensors on board. That's, with that one specifically, that's not the problem. But because people don't know what it's going to do, they don't have any idea. Versus, Dax will get to the street corner, and like a human, it will look at you. And it will watch you and follow your vehicle as it drives past. So this thing sees me and it's aware of what's going on. And it can nod its head like, yes, you can go ahead, or, shake its head so that people know, you want me to go versus you're going to go, right? And so there was a lot of thought and intentionality into the neck.
Yeah.
Isn't just necessarily for the neck's sake, but it's more for communication.
It looks...
One of the design... Oh, go ahead.
It looks to me... So... Thinking of like the founder's perspective and this kind of thing, perhaps it had something to do with making it so that, I mean, if you have sensors everywhere and you can get a really good rendering of the world and this kind of thing, you can design behavior that uses that understanding of the world. But in this case, you're kind of constraining the behavior of the robot to be something that seems more natural.
Correct.
In like it has to go and look behind it or something if it's going to go and back up, or if it wants to like look both ways for the street, you have to do that with the head. And it basically constrains the developers to like I don't know, program more lifelike behavior in it so that it operates in the world. I could see that being a
Oh,
clever way of doing that kind of thing.
100%. And for engineers, specifically the mechanical engineers, they would much prefer to have the device to be a cooler, right? I mean, they could, right?
Yeah.
That's a much simpler thing than a fully articulating neck with dual pitch motors, right? So,
yeah, or just, I mean, all the
so
sensor information would be probably more valuable.
Absolutely.
Like, who cares if it
Yeah.
looks like a cooler?
Yeah.
But I get you're meaning that for like sensors everywhere and full 3D map of the
Yeah.
whole environment that it's in and this kind of thing.
Yeah.
Mm-hmm.
Yeah, absolutely. And we've, obviously we've got, that technology to be able to do that so that Dax is able to learn in 3D space and, instead. But again, more similar to, a human. If I'm walking down the street and I've been down that street before, I have an idea of what to expect, right? I know there's a curb there. I know there's a telephone pole.
Mm-hmm.
I see, there's a box there. I've never seen that box before. Okay. New information. It might not be there tomorrow, right? So it's not something that really comes in. But because everything is changing in such a rapid space. Again, on a factory floor.
You mean in the environment you're walking around?
Correct. Yeah, in the environment you're walking around. If you're walking downtown, in a metropolitan area.
Yeah, there's a lot of moving parts.
It's changing all the time. Yeah, exactly. So, being able to have something that is more lifelike to be able to adapt in that environment, and it seems more natural in that environment, actually, which is pretty interesting.
So, what sensors are on this robot, on the Dax robot?
Yeah, so disparity vision is one of the big
it has a stereo. It has two cameras beneath the kind of chin or something, right below the display.
Correct.
And
where you see the display of the eyes is where that
just
where
beneath, beneath it. Yeah, because I think I see the little circles from the cameras that it has to. So you have the two cameras, and from that you can infer some 3D information about what's in front of the robot. Okay.
Correct. Yep.
Anything else? I mean, I imagine there's encoders and things on the wheels or on the track. What other? And then all the motors have sensors and things. But what else for perception? Is it just those cameras? Maybe microphones?
Yeah. Yeah. So it's got stereo microphones. So you can hear what's going on. Again, kind of that sense. If you're a human, you can hear somebody coming up behind you, right? You don't have eyes in the back of your head, but you can hear that something is happening. Yep. And you're more aware of your environment that way. So yeah, those. It's fun when I talk to people about sensors. A lot of times they're thinking very unilaterally, and they're thinking about
like LiDAR and things.
Yeah, exactly. Yeah, like LiDAR, ultrasonics.
I mean, I'm honestly surprised you don't have like a planar LiDAR or anything in there. But if you can do everything with vision, that's great.
Yeah. Yeah, it's pretty fascinating. Obviously, the tracks have sensors, things like that. When we're going into, autonomy, things like that, being able to have tracks to be able to know, even if you lose, GPS signal and that kind of thing, you're able to know within, a centimeter to where you're at in space.
Oh, you're saying the tracks are very accurate for encoding. And that's probably because they don't slip as much as wheels might.
Correct. Yep. Huh. Yep, exactly. So
gotcha. Okay, so going back to the neck, you have these two cameras, and that's the majority of that is the big perception sensor, the two cameras, and then you have stereo microphones.
Correct.
Or whatever it's called, so that you can tell directionality of the sound, right?
Yep. Correct.
That's pretty much it for perception, other than like actually, I forget what it's called now, like dead reckoning your position from the tracks and this kind of thing. But that's it?
Yep. Yeah, that's it.
Do you have like, are there like capacitive sensors so it can tell if it's being pet or hugged or anything like this? Or how do you detect like a person is nearby or interact? I guess the cameras would do that, but do you have anything for a person touching it or anything?
No, not. And we've talked about that a little bit. It's not. We don't know how helpful that would be at this point. Everything has to have some lead time and stuff like that.
What do you mean lead time? It just takes time to do. Is that what you mean?
Just takes time.
Gotcha.
Yeah, just development time. And so weighing priorities. Which is the most important thing.
Totally.
But yeah, with the vision, for example, if somebody sneaks up behind me and touches me, I would know that, and maybe the robot doesn't at this point.
I might do it by sound.
But being able to hear that somebody's Yeah, exactly. Somebody's coming up behind me, I can look back and be like, oh, hey, what's going on? And then, we can have a conversation. So no perception as far as that's concerned.
Gotcha.
But
I was just curious with like interacting with little kids and stuff, if like the little kid would pat it on the head and it would know it was being pat on the head.
Oh yeah. But people are hugging it all the time. But
Okay, so the neck. Tell me about the neck. So how many degrees of freedom does it have? What kind of things can it do?
Yeah. So not wanting to be super creepy, so we've limited the range. So
it can't go all the way around like an owl or something.
We don't want this. It's Halloween. But,
no exorcisms.
Robot, right? Yeah, exactly. So it's a limited range view, just like a human would be. So it will go back probably a little farther than a human would by itself. If I just turn my neck, I can get about 90 degrees. But it doesn't go much further than that. So we also don't do a full 180 either, and so it's about 150 degrees.
Oh, that's pretty far.
Direction.
Okay.
So you're looking over your shoulder, right? You can look back and see what's going on behind you. And then down, basically similar to a human, right? You can sit down, touch your head, and then the other problem is looking up. You've got the back of the head, right?
Because the cameras are just beneath the chin, in a sense. So it really does have to look up to kind of clear the chin, right?
Yep, exactly. So, so that's fully articulating in all other directions.
So that's 2 degrees of freedom. Can it turn sideways? I think it probably can, right?
Yeah, oh yeah.
Like you
being able to
kind of kink the neck. Yeah, tilt the head like a question.
And one of our and that's one of the most favorite ones that we have, especially when we're interacting with kids, or they want to play with the robot, and so the robot, kind of like a dog, will cock its head and look at you funny. So that's one of the things that we love doing with people. Yeah, kind of like, huh? And then a couple sounds that we put into the robot. So
I've heard them. They sound Wall-E-like in some of the videos, which is interesting. Yeah. I mean, Pixar did a wonderful job, so may as well leverage a lot of their things.
Yeah, absolutely. Yeah, but it's pretty fun. It's with the sounds, people ask, if it can talk in some language, English or whatever. And the answer is, well, yeah. Technologically, that's easy. Simple to do. Yeah, but we've made a decision to not. And again, the reason for that is when you don't expect a dog to talk back to you, in a language. But it will bark, and you can understand with nonverbal communication what is going on. And so, in the same way, as we worked with different robots in urban spaces, and they would talk to you in English, it doesn't matter how nice the robot is trying to say something in English. It comes across rude. You don't expect a device to be telling you to get out of the way, right? It's like, well, that's kind of rude. Versus a robot that is just making sounds, more R2-D2-esque than anything else, right? So that you understand, like, oh, this is asking me to move. I was actually just having lunch today at our local Mexican restaurant, and we have a robot down there that's doing deliveries all the time. And the robot had come inside, and then there was a cup in the way where it's supposed to park. And so it's looking down, then looking up, looking around, its head like, hey, come over here, and putting sounds. And then just somebody that was at the restaurant looked at it and was like, oh, it's trying to tell me something. Went over, picked the cup, got it out of the way, and then the robot was able to say thank you, turn around, and back into its spot. So one of your robots, you're saying? Yeah. One of your DaxBots? Yeah, one of the ones like this. Yeah. So with it nonverbal communication and that human robot interaction piece is, again, a lot of stuff that we've studied. So it's where we put a lot of time and effort into. Yeah, it seems like a thing of setting expectations, because I think if something talks, we expect that it can really talk. Right. And then it's frustrating when it immediately doesn't recognize you. Like, you could say any arbitrary complex thing and it would have no idea unless there's someone behind the scenes. Kind of like those, right? Yeah, like a web chatbot. You're typing in, and you're like, no, this is definitely a chatbot. This isn't a human talking. Yeah. So the robot would be similar to that. Otherwise, I've seen that quite a bit from like different human-robot interaction research where they want to set the expectation low, so that they can not overpromise. Right. And obviously, other companies have done a good job of overcoming that barrier by having an actual human, via like a computer screen on the other side.
Mm-hmm.
And then you're talking face to face with a human, right? The robot just happens to be, the carrier.
Yep, it's the medium
of the iPad. Or
for sure.
Yeah, exactly. So
do you, so how much of the robot's control is a human in the loop? Like teleoperating the robot, and how much is autonomous at this point?
Yeah, at this point, the autonomous piece is almost strictly for navigation. Mm-hmm. So now that part's out of the way. One of the things, obviously, the software guys, they're really excited about the HRI components automatically. Facial recognition, is somebody happy, sad? How do I
some emotion.
Interact with them? Yeah, putting emotion, but while it's on the job, if you will, especially with disparity vision and making sure that, collision detection and avoidance and things like that is all
working.
It's going down a path, making sure it's not going to run into something.
Mm-hmm.
But at the same time, it comes into an obstacle, if it hits an obstacle, not hits an obstacle, what I'm saying? It sees an obstacle, stops, and then can look around. And it's kind of like, looks like it's looking at flowers or trees or cars that are passing by, so that it is more natural than, a robot that just drives, gets to a point and then just kind of sits there for a while.
Yeah.
So all of the human interaction pieces have been with teleoperating, having somebody on the other end, being able to emote. And it's been really fun to, again, experiment in a pretty tight loop, so you can see what do people react to and what do they want. Like, what do they want to see from this robot on a emotional or interaction basis. And then once they have that, now that we have some really good data, now just programming, right? Just program it like, okay, when this, then this.
Yeah.
And then the robot can know what to do in certain situations.
So the robot will autonomously go from point A to point B. It uses GPS, or how does it do that?
Yeah, GPS and dead reckoning.
And dead reckoning.
Right, yeah. So within the tracks itself, it knows where it is, less slippage, like you had said.
Yep.
Better than wheels.
Does it use?
For that?
Is it doing? It's not generating. I think in us talking a little bit before the actual recording started, it doesn't do mapping. Right, you have to go map an area before the robot goes into that area. Is it correct?
Yeah, for the autonomous piece.
For the
correct.
autonomous piece.
So when we go into a new area, we have an operator that's doing that piece. Going through, finding out where the obstacles are, stuff like that. And so here's the road crossings. Here's the dangerous paths.
That's cool. Yeah.
Don't go here. Kind of like the Waze app. Yeah. So once we have all that set, then we can say, yeah, this is a free and clear sidewalk. You can go, full speed. This is a danger zone. Slow down. This is a road crossing. We aren't. That's a lot more programming. We aren't letting the robot cross streets by himself.
Yeah, that seems terrifying
that part.
For your robot.
Yeah.
Yes.
Yeah.
So what is it when someone is going to create one of these maps for the robot? What does it involve? Do they just like a handheld stereo camera or do you just bring a LiDAR through it and it just maps everything, or what? Like, how do you create this initial map?
Good question. We actually just do it with a robot.
So you drive the robot
actually just
through.
Take a robot to a location,
Huh.
which does.
And you generate a big 3D map that way, and then you annotate it.
No, it's a little more complex than that. I won't try to butcher it because I'm not one of the engineers on the project. But but being able to go through. And then with that, being able to process all the data that we need so we can see here's what's going on. And it also does a lot of good stuff. When we're doing bigger deployments, one of the things that people really want from our customer base is Dax is really cool. It's a really cool thing, right? It just happens to be cute and it delivers food. So, what it does is kind of an accessory. So when we go to a new area, it brings a lot of goodwill to the people that are getting it as well. We're driving a robot on every path that we can think of, for a delivery area, and people are stopping us all the time asking questions.
Oh, yeah,
what is this robot? It's like, oh, yeah, we're partnering with this person. And so, and then it also gives us some good information as well for the other connectivity, LTE and stuff like that. So when operators have to jump in, we got to make sure that we have what carrier do we need to use
for the different
what kind
locations.
of frequencies are up here, what bands, right? Yeah, because everywhere's a bit different. And so obviously what will work in here in Oregon is not necessarily the best carrier down in Coronado, California, which may not be the best carrier in Atlanta, Georgia.
Yeah, gotcha. Okay.
Yeah.
So you have a map of the environment that you get from driving the robot through it. And then you have the robot navigate autonomously from point A to point B using kind of like somewhat a labeled map in some way where someone says this is a crosswalk, this is a sidewalk, these kinds of things. Then you get to your destination and the robot is taken over by someone who's controlling it with a teleoperation setup to actually do the delivery to it, correct?
Correct, yeah. So that at this point, knowing that, that's the interaction piece.
Yep.
It's not just the delivery service, right? It's the experience of having a robot that is being nice to you. Yeah. So that's where a human takes over and is able to be interactive with people.
And so for that part, what does it look like from the human's perspective? Are they sitting on some sort of like video call kind of thing that sees what the robot sees and they have a bunch of buttons in front of them where they can say nod head like this, make this noise, like this kind of thing for picking the behaviors, or how does it work?
Yeah, a little more simple than that. A couple joysticks, that have a lot of pre-programs into the joysticks. Kind of your overview map. You can kind of see where the robots are at. You can monitor several robots at a time. Making sure they're staying on path, and then if one needs help, the operator's able to look into it, see what they need to do, navigate around, or end of destination, right? Being able to contact the person, let them know that they're there. The person will come out.
That's funny.
For the delivery.
It's like Uber Eats or DoorDash or something.
Yeah.
When you have to call them and be like, where are you at? Yeah.
Yep.
That's funny. Okay. Let's see. So then, so they're using a simple interface to control the robot while they're doing that interaction. You were saying that eventually maybe you could automate this kind of thing. Are you, or at least part of the interaction now that you're generating data? How, and then do you have the customer like rate how enjoyable it was, or different metrics of it so you can see how the interaction was and what parts of it they liked and disliked and whatever?
Yeah, that's a good question. So there's not like a Dax app, for example. People aren't ordering food through us to get.
Not yet.
We actually work directly with. Yeah. Well, it's an interesting paradigm. We work with the restaurant, and so we'd rather do integration with people so that it's their brand. We just happen to be the courier robot that's delivering.
Yep.
Yeah. Kind of like I lived in Seattle, and Boeing obviously is a great company. But, a Boeing airplane could have Alaska Airlines on the side, or it could have Delta or United or whomever, right? So so when I go to get on my plane, I'm not saying, hey, am I on a Boeing? I'm with Delta this time, or Alaska or whomever, right? So so kind of the same, kind of feel. But with that, so especially here in our local town, it's a small town. And so being able to, we've got their phone number, and then we can ask, direct conversations and see what people like and don't like. We did a test at a retirement community as well. I mean, the assumptions that we had were we know kids like robots, which I think back to when I was a little kid. And I've got a 8-year-old and a 2-year-old, and to them growing up, oh yeah, robots are on the street, like it's just kind of a normal thing, right? Yeah. So I'd imagine kids probably are good with it, and they love Dax. People our age are a lot more amenable to Dax as well because it's cool technology. So we didn't know how it was going to be, received with people in their 90s, and shockingly, Dax was super well received in the retirement community. Oh yeah. Again, because it's not a machine to them; it's an entity, right? So when you watch Star Wars, for example, R2-D2 isn't a machine. He is, but you don't perceive him that way. You perceive him as an entity, somebody that you are having conversation with, not just directing to do a thing. So So in the same way, when people see Dax, and it's funny, I do the same thing. I know what's behind, I know, all the inner workings of the robot, but I'll see him on the street while I'm, going to get a taco. And I'm like, hey, Dax, I'll say hi. And it's so funny. And obviously I know, it doesn't, you know what I'm saying? But it's definitely an experience. And until somebody experiences or sees the difference between, just, a cart that can deliver something to you versus having an interaction with a being that is a machine, it's starkly different.
Mm-hmm. Now, so you guys are deploying in your town. So you're in Portland, right? I haven't been to.
No, not Portland.
Oh, where are you?
Yeah, not Portland. We're Oregon State University, Corvallis, which is about an hour and a half south, and then we actually are in a small suburb of that.
Gotcha.
In a little town called Philomath. But so not Portland, not in a huge metro.
Yep.
But yeah,
small town. How many people to the town?
Oh, about 5,000.
Wow.
So small.
It's crazy.
Small town. Yeah. Small town. I moved down here from Seattle.
It's a big change.
It was a good.
Yeah.
Yeah. I grew up in Montana personally, so it wasn't a huge change to go back to a small town. Right. Yeah, we've got robots now that are in Coronado doing food delivery down there.
Mm-hmm.
And that's been fun. We got some robots that are shipping out to Georgia next week, actually.
Oh, hell yeah.
Yeah, so we're getting them packaged up and shipped to Georgia, and then different deployments. I think Long Beach, we've got some robots in Long Beach right now.
Yeah.
Doing some deliver stuff, and then, and more people are contacting us all the time.
Hell yeah.
More, yeah.
How many robots are deployed right now, would you estimate?
What? I don't really I could probably do the math in my head. It's not a lot. So we've got the deployment in Coronado, Long Beach.
Here, is it on the order of like one's going 10, to Georgia, or is it on the order of like?
Yeah, it's about. We've got more robots than that are coming off the production line, but we've got actually in the field working. Mm-hmm. We've got about 10, 9, 10.
Gotcha.
That are doing stuff.
Okay, interesting. How large are you guys as a company? Like how many people are involved?
Yeah, so there's 18 of us.
18.
So we've got the manufacturing. Mm-hmm. So we got the manufacturing side that is, getting robots, off the line. Mm-hmm. Then obviously the operations side and servicing. Just like getting data on that. How long do you have to run a robot before the tread needs to get replaced?
Yeah.
How many miles on their tires? Before
I would imagine the treads wear out fairly fast too, which is interesting.
Surprisingly, not.
Really,
they actually have lasted a long time. We finally got one that we're like, hey, this looks like it's starting to wear out. We should swap this out.
Gotcha.
This actually just happened. I think it was either earlier this week or late last week. And so I asked our operations manager, I'm like, figure out how many hours we put on this thing so we can put that in our service manual. But
yeah.
So, yeah. And then obviously the engineering team, the mechanical and electrical and software and firmware. And so.
Gotcha. Cool. And how are you guys funded for this kind of thing? Have you been accepting investment, or like where are you at in terms of funding?
It's a great question. So in 2000, two brothers, I'll tell you the story of the founders. So two brothers, they started an ISP, dead broke. I mean, they were volunteer firefighters, lived at the fire station, paid themselves $50 a month kind of thing.
Crazy.
Barely getting by. Got it up and running. And then in 2011, they were still kind of limping along. Since they were firefighters, one of the brothers had this idea because they went to a fire call. They got to the fire station, and the fire trucks were coming back from the call by the time they got there. And he's like, "This is stupid. Like, we have the iPhone. I'm going to build an app." And so he built this app called Active 911. And last I heard, it's about 40% of firefighters in North America use this app called Active 911.
Wow.
So it's done very, very well. But that's Joseph. And Joseph's goal was always to have this R&D lab that I talked about. So in 2015, they started Nova Dynamics. And then Dax was kind of the first big project that they said, okay, 5 years from now, I think robots doing delivery is going to be a thing. So let's start working towards that end. Mm-hmm. And more importantly, working towards the future that people want to see. When people are thinking the future of electric cars have been around, since the 80s.
Yeah, a long time,
people
for
have
sure.
tried to do electric cars. But it wasn't until Tesla before now it's something that people want, right? People are like, oh, That's the vision of the future that we want to see, not these weird box things that are glorified golf carts.
Yeah.
Right. So in the same way, with the robot is solving that, what kind of thing do we want in pedestrian spaces that isn't going to be creepy, that people are going to want to attach themselves to, that can do helpful things for people. So that was the idea. Mm-hmm. So the R&D portion has all been self-funded, because of these other two companies that have done well. Mm-hmm. It's been self-funded up until about a month ago. Mm-hmm. And so about a month ago, I was actually, in January when we said we need to commercialize this thing. What do we need to do? We need to get investment because, building, 20 robots is one thing. Building a fleet of them, hundreds is a totally different ball game. So it was actually just about a month ago that we opened up a crowdfunding campaign through Start Engine, which is the intermediary. So it's kicked off, and this is the first time I've been involved in lots of companies. Started a couple myself. Yep. But I've never gone after investors, so it's a whole new experience for me.
You mean crowdfunding specifically, or in general,
or even venture capital? Filing with the SEC. Yeah, I've always been bootstrapped. Yep. Right. We've always bootstrapped companies. So this is the first time going after investors, and it's really interesting because the majority of people that don't know us, they don't know who we are, and they don't understand that the two brothers, like people that know the two brothers, a lot of people that know them have invested quite a bit because
they think they're doing
successful
good
in
things.
other ventures.
Yeah.
Yeah. And they've seen the robot. Obviously our hometown, couldn't ask for a better reception, from the investing standpoint, because they're like, no, this is our robot. This is our hometown, friendly neighborhood robot that we're investing in. But people that don't know us, that have invested, we're saying over $1,000, $1,000 or more. Yeah. We've been reaching out to those people, and predominantly they're engineers. It's people that see what we're doing and they say, oh, this is cool. Like, this is a cool version or vision of the future that you guys have, and we want to be a part of that. Cool. So, so that's where learning, how do we get that message out to more people? So not just engineers, but
everyone.
But it seems to be interesting that that's the community that is really liking what we're doing. So
yeah, well, they're interested. I don't know. As an engineer, I'm interested in robots, and I imagine it's true for a lot of other engineers.
Yes, it's true. And it's not just, robotics, every discipline you can imagine. Civil engineers are like, wow, this is neat. So it's kind of cool.
So how is the crowdfunding? What are your thoughts on crowdfunding after? So is it still live or?
Yeah, it's still live.
So at the time of this interview, it is. How long will it stay live until? Because it may be, I said it'll be like 3 weeks before this is published. So
yeah. So the raise is going through either till you hit the first goal that we can hit with what we filed with the SEC. So we're looking for $1 million by the end of the year is kind of the goal and the target that we have. We're about a third of the way there, after been going for about a month. So nice. We'll either hit that mark and the fund will shut off, or I believe it goes until, I think it's a 6-month campaign. So it would go until then. April of next year.
Oh, hell yeah. So, okay, good. So this episode will air while it is still going, if it goes to the 6-month time. Awesome.
Yeah.
What have you thought of crowdfunding? It's an interesting model. Does each person get some equity, or they're just supporting you, or they like get a Dax robot, or how does it work?
Yeah. So there are different ways of crowdfunding.
Yes.
If you were a nonprofit or something, it's not equity. What we're doing is actually equity. So you're actually getting stock in the company, which is kind of cool. So
I've heard horror stories of that. Where you have crowdfunding where you give them equity, because you'll have to go and get permission from everyone for all the decisions, and it eventually just like bureaucracy weighs down the company and no longer gets anywhere. Yeah. I guess you have to be very clear about their terms, kind of thing, if you do this.
Yeah. And everybody, Start Engine is the platform that we're using, and part of it is that yes, you do get common stock. Which is you have shares in the company, but you also are essentially signing over your vote to the CEO, which is me. So when anybody says, yes, I'm going to put $1,000 into Dax and get, however many shares, they're also saying that, okay, I know that
you
I'm a minority shareholder, right? So I am your representative. So I am the vote for the shareholder. So obviously, if people want to talk to me, obviously, and let their voice be heard, kind of like a representative government,
Cool.
And
okay, I like that a good bit better.
Talk to me. Yeah, and then same thing where it's exactly, because otherwise, your shareholders meetings, everybody's there by proxy, and I am the proxy, and I am the vote. So it doesn't really bog us down administratively, if that makes sense. Yep. Yes, the cap table is big, and usually people that don't understand technology very well,
and
that's
cap,
like, oh,
cap
we're going to have to
capitalization, which is where the money of the company goes, right? Like, or who owns what, basically.
Correct.
Right.
Yeah. Who owns what? Yeah. So if you buy, 50 shares in DaxBot, your name goes on the list of like, okay, you are an investor. So, yeah.
Okay, that's crazy. Yeah, that's well. At least we have you can automate everything, so you don't really have to do too much. Probably management.
I know that's what I was going to say. Yeah, there's not, and people that don't know technology very well, they have in their mind that you're licking, that many stamps, and envelopes as you're sending out requests, to shareholders and things like that. It's like, no, you put it in a CSV file and boom, everybody gets a mailer.
So how much? So you said your goal is $1 million. You're a third of the way there. It's been a month.
Yep.
You have 5 more months or so. How many? So in that third of $1 million which you've collected, how many people are involved in that?
A little over 200. So
wow. Okay, so it's mostly at least investing. They're at least investing $1,500 per person on average, kind of thing.
Yeah, that's the average, and we had to have a minimum that was above 100. And so what we wanted to do, and back to the large cap table, right? The number of people that would be on this this list of investors. People were saying, don't make it too big, but at the same time, we have a lot of fans. We called it the Dax fam. And we wanted people to be a part. And so we said, okay, we need to have a minimum. That minimum entry is $170 so that people can be, an owner of DaxBot.
Why that arbitrary number? Why $170? Well,
yeah, so I like round numbers personally, and so our it's $169.50. So with our current valuation and what the stock price is, it ends up being 50 shares. We had to have a number over $100.
Okay.
And so we said, okay, well then 50 shares. So 50 shares is $169.50, $339 a share.
Oh, I see. So okay, so that's how it worked out.
Made it simple for me. Yeah. So I just made it. It was arbitrary, but it was okay. I have 50 shares of DaxBot, right? That became kind of the lowest investment that you could do, and then up to answer your question, so up to $50,000 is if 50,000 and above. If somebody wants to invest at that level, we said, yeah, we'll fly Dax to your location and we'll have them deliver something to you.
Cool.
So we haven't. Nobody's taken us up on the 50,000 yet, but we've had a few investors that invested, several $1,000s, and the average is about 1,500, but I think there's a lot of investors. The majority of the investors, if you will, are about $1,000.
Gotcha.
So it's been a good reception.
And because it's, I don't know if I know this correctly, but this is my impression, and you can correct me. Because it's relatively small amounts of money that people are investing, they don't have to meet the bar. The people investing don't have to meet the bar for being like an angel investor or something, which I think is like $1 million in net assets or something, and over some amount per year. So anyone can invest in this kind of thing.
Yep, exactly. And that was a law. I might get it wrong, but it was fairly recently. I think when 10 years or maybe 15 years is when the law came out.
Oh, did it?
Before that, you're right. Everything was an accredited investor, which, like you said, massive amounts of either high income, a high disposable income, or huge net worth that isn't your house.
Yeah.
And so it's very rare air to be an angel. Yeah, exactly. And so with that, they said, okay, there are some rules around it. So, for example, if you go to Start Engine and you say, I want to be an investor, they will ask you some questions about your income and things like that. And then
to confirm.
Because there are limits.
Okay.
Yeah, and to make sure that if you don't have a lot of disposable income, you're not
doing it.
Going to hurt yourself, right?
That's good.
Yeah, exactly. So, yeah, and there are certain limits and things, again, depending on income and assets and things like that. So it doesn't hurt anybody. But at the same time, people can invest in cool startups like this.
Oh, totally.
And it's kind of
share some
fun
of the wins early too.
Yeah, absolutely. So they can say, a lot of people are like, well, I don't want to put my, people that are okay putting money into crypto are usually okay putting money into startups, right? it's not people that just want bonds, right?
Yeah.
I don't want bonds and put it
They
under my
want it to
mattress.
grow massively and
I
have that
want,
hope.
I want it to be something cool.
So if they're okay with a bit more risk, yeah.
Yeah. So, and again, and it's not, for a lot of people, $1,000 is not like it
doesn't break the bank, but yeah.
It doesn't break the bank, but if it goes big, like that'd be cool. And again, it's more part of a, I've met people that invested in Microsoft when it was nothing, kind of thing. And it's like, oh, wow, you're probably enjoying that.
So one thing that I would be curious about if I was to invest in this is about future rounds of funding, because it might be possible that they get diluted through additional funding. How does that look for, I don't know, just talk about that because I don't know too much about it.
Absolutely. Yeah. I didn't either, till, a few months ago when I really had to learn a lot. So the way that it works is that the goal when you go to each investment round is to the value of the company wants to go up, right? That's the goal. So if the value of the company goes up, so does the amount of dollars, easy math. If you invested $5 and then the value of the company doubles, then your $5 turns into $10, right? It just, hypothetically.
Yeah,
so the value goes up. But then, then you say, okay, we're going to go after other investors. So we're going to add more shares to this pool, which is going to dilute your shares, right? So your share was $5. Now it's $10 because we doubled it. But now we've put more shares into the mix. So now my shares are worth $8. But it allows more fuel for more growth, if that makes sense.
Yeah.
And the hope is that it grows again. So then that 8 turns into 16 if the company doubled again, right? So that's essentially how that works, and that's a very simple, very, very simple.
Yeah, but the dynamic is there.
Yeah.
And you just hope that it's not diluted to such an extent that you make quite a bit at the end if the company does have some sort of liquidation event.
Yep, and that's the goal. And I've, talking to venture capitalists and angels and just kind of getting a sense for what are you looking for? What is an angel investor or a venture capitalist looking for?
What do they think of crowdfunding?
Most of them have no experience with it, at least the ones that I know or that I've talked to. Most of them have no experience with it because they haven't had to, right? They're that rare air of angel investors, accredited investors.
Or they're working for an investment firm or something and just kind of throwing around the money.
So a lot of people, and since, again, because it's a fairly new concept in the scope of, the history of the world, it's a fairly new thing that you can get into these crowdfunding rounds. They don't have a whole lot of experience with it. But a lot of them, it seems that the tides are turning a little bit. I'll give an example. So there's an angel group called Oregon Rain. And it's more for small startups. I need $30,000 to get this idea off the ground kind of thing. And so because they're angels and trying to figure out how they're going to do it, they actually partnered with another intermediary. I can't remember, but basically who it was. But essentially this other intermediary, like Start Engine, was going to give them a white label version of
what does it mean, white label version? I don't know what that means.
So a white label version would be, so for example, if I have a software, let's just call it Microsoft Office or Microsoft Word, right? So
sounds like a
white label version of
Okay.
So I can't just say, hey, it's Microsoft Word.
Yeah.
But if I had a white labeled version, if you came to me and said, I'm going to give you, $300 billion, so I have a white labeled version, it's not Microsoft Word anymore. It's now DaxBot Word, right?
So you buy the label or you buy the...
Essentially.
Okay. So
you buy the rights to the software, but they put your name on it. And so that's... so a white label version of Start Engine would be, OregonRain.com/investors. But the actual software was not written by these investors. It was written by another company. Yeah,
that makes sense.
It looks like it's becoming more. There's more awareness around crowdfunding in these angel groups. It seems like.
Okay, that's what you were. So I was a bit lost for a sec. You were saying basically that's an example of crowdfunding going into something that is a bit larger, with investors or something.
Right. Yeah. The angels they know of it, but they haven't participated. But it seems to be. just the research that I've been doing, it seems to be that they're more open and receptive to it.
Interesting.
More because you have companies that have gone through crowdfunding rounds and they've done it successfully, meaning that they got the money and then they executed on the goal correctly. They started getting revenues, and now they have revenue. So now they could go into like an angel investment group or venture capitalists and say, "Here's our revenues, and here's the funding that we got before. Now would you invest in this?" And they're now seeing, because they're seeing this happening more often, they're more privy to the fact that, we might want to look into investing in crowdfunding options ourselves.
Huh. Why would a company go into crowdfunding as opposed to seeking investment from, I don't know, like a pre-seed or some sort of company or some sort of angel investor or something like this? Because I understand that one of the benefits of having investors come together for your company is that they can help you they can connect you to the right people, or they can mentor you so you avoid potholes. Why would you choose crowdfunding over like one larger investor kind of thing?
Yeah. Two main reasons. So January of this year, when we were looking at going after investment, reached out to some venture capitalists and friends of friends that we have that know people. And essentially all of them said, okay, well, what are your revenues? Zero. Okay, so if your revenues are zero, that's a pretty big gamble, right?
Yep.
For them. That's
you haven't
the
found
perception
market fit or these kinds of
right.
things
and
yet
so,
in their eyes. Okay.
Yeah. So at this point, they would look at that and say, it looks like it's still in like a research phase. It's like, but we want to go from a research phase into a commercialized phase. So in order to make that jump, it's going to require money. And so I was talking to one venture capitalist who'd been on the other side of the table too, right? He'd had startups, gone after venture capital, and had some successful exits. And he said, what you're going after right now is, he called it dumb money, for that reason, right? Because when you go after venture capitalists, you're getting their Rolodex, right? The old Rolodexes where people had contacts and things like that. And so you're going after their Rolodex as much as you are the cash. And so that's kind of the next step that I see.
And also just advising too, not just Rolodex,
absolutely.
but like they can really know, because they could have seen people go through similar stages, and they can be like, like at this point you should be working on this, and at this point you do this, and this is how we get to the next stage, our Series A or whatever it might be. Yep.
So so as we talked to different people, essentially it was, that was kind of the feedback we got from several, get some revenue and then come back to us kind of thing. So we looked at that and said, okay, well then crowdfunding seems like a good option for a few reasons. One was because everywhere Dax goes, he's a celebrity. Everybody, cool. Not everybody. There's about half of the people will kind of walk by like, I see robots trying to talk to me every day. It's like, there you go.
Man, I'm in San Francisco. Cool. Where is this? It's like, I don't know. I feel like I should be in the area with all the robots. And you were mentioning that it's not legal for robots to drive on the streets here, but I'm supposed to be in the tech area, and I just so seldom see robots anywhere doing anything, especially with all the work from home stuff. But yes, okay,
right. And then the other half of people are getting out of their car. We haven't caused any auto accidents from people like rubbernecking, but it is fun being walking. It's fun walking behind Dax and seeing people on the road, because people will look, and even if they're having a bad day, it's funny watching the people in the car, because they will turn their head, look at the robot, and they'll look at Dax, and then everybody smiles or has this look of like astonishment. Like, what is that? Did I just see that? But everybody smiles like, whoa, that's cool. Like, I just saw something special today. So anywhere the Dax goes, he's a celebrity. Like I talked about, the hometown Philomath, we wanted to be able to say, hey, you can invest too for crowdfunding. So give you that opportunity. The other piece of crowdfunding is it's a lot of marketing, right? Philomath it's a great little small town, but it's a small town. I moved down here from versus Seattle. You got 4 million. It's not as big as LA where you're coming from, but need more eyeballs on Dax, right? Because the more eyeballs that see Dax, the more people that have a vested interest, literally, right? If somebody is in Texas and they put $1,000 into Dax, they're probably also more privy to be like, hey, I want Dax down here too, or what
Cool.
connections do you have in
Okay.
a larger sense, if that makes sense. So those were the two big reasons that we said, yeah, let's go after crowdfunding and make it work. So
What do you think of? So coming from, so I was in grad school doing human-robot interaction for a little bit,
oh yeah,
and
nice.
one of the things that was very concerning for the community was kind of this novelty effect. So like someone can be like really excited about the robot, and they'll like do all the things the robot wants and behave really well around it. But then over time, so as weeks go by and months go by, like maybe the robot becomes less influential on those people because they now are like, I know what it does. I'm kind of sick of it. This kind of thing.
Yeah.
Any thoughts on this? Because the robot is currently a celebrity, but I wonder, could it be a novelty effect, or is it? How do you think of these things?
Yeah. So if all that Dax did was be novel, I would agree with that.
Mm-hmm.
Right. So
but it
he
actually
has to have
delivering
some
things, and so
right.
that's what
He
you
has
mean?
to have a useful function as well. Right. So if it is so same with I would say that if it's doing useful things for people, whether it's delivering you food or patrolling grounds like a security robot or something like that, right? If it's doing something useful, it's not only novel and cool. You wouldn't get sick of it because it's actually helping.
It's justifying its
in
existence.
a real way.
Yeah,
exactly. Especially in the delivery space, because delivery, if you look back to the 1970s when they started tracking it, it's called the labor force participation rate. And
So is the U.S. government tracking it, or
yes,
like
U.S. government, yeah, Department of Labor.
Okay,
Yeah, the Department of Labor is looking at how many people are working compared to the population, and that number's been in steady decline since the 70s.
it's crazy.
COVID exacerbated that.
Yeah, I bet.
Where there's less people working. And at the same time, if you look at just food delivery service in general, that's been on an increased, exponential growth path for the last several years. COVID exacerbated that as well. So the restaurants and the people that we talk to in the delivery space, it's almost an expectation now, where if you own a restaurant, food delivery. If you own a restaurant, yeah, exactly. It's the expectation. You might not. But Uber Eats or Grubhub or DoorDash or somebody is going to deliver this food to me, right? It's kind of the expectation.
Yep.
And so that's maybe, I don't want to say an unrealistic expectation, but when you don't have enough people to fill those roles, it's just not going to happen. So, for example, in Coronado, one of our guys walked into one of the restaurants in the back and they said, do you see all those orders? And there was like 20 delivery orders sitting. They're like, they've been sitting for hours. And there's nobody going to come pick them up. Like, very doubtful that somebody's actually going to get on Uber Eats or Grubhub or wherever and go and pick those orders up and take them to the people that want them. Last delivery experience I had when I was on a trip to Montana is we had delivery set for 11:30 for lunch. It was only 5 of us in the room. Said, okay, lunch is going to be here at 11:30. We ordered it ahead of time, make sure we got in the delivery schedule, and it didn't show up till 2 p.m. And that's just because of, there's not enough people to fill those types of roles.
Is that a thing that's more particular to small towns, do you think? Like, basically, is the whole, like, say, middle of America that would have smaller towns? Or basically any, because I'm thinking of, like, I'm in San Francisco now. And generally, it seems like the food delivery services are quite quick. But maybe this is, so it hasn't been in my experience, as you've described, where there's like 20 orders for this kind of thing. Is this particular to any locations, I guess? Or any types of cities or any types of towns?
Yeah, that's a good question. So Coronado, California isn't exactly like, rural middle America.
Yeah.
Yeah. It's right outside San Diego, but it's right outside San Diego, right? You got to go over the bridge. So it's also a very wealthy zip code. And so if you are living in Coronado, you're probably not the person doing the food delivery. That makes sense. So people have to come in and then do the delivery within that area. So so that's kind of a unique thing. The other thing is that a lot of people, DoorDashers and people that do Grubhub and Uber Eats and stuff like that, a lot of them don't want to do the short stuff.
Yes.
Similar to like your Uber driver wants to drive you 30 miles away to an airport. They don't want to drive you 3 blocks, right? Because They still got to
Depends what
pick
they're
you up. They still
optimizing
gotta,
for, but in general, because
yeah,
some of them are trying to do
in
a number
general,
of trips and
exactly.
these kinds of things.
Right. Yeah. But in general, you're making more, if you will, the longer you have. Yeah, you're doing the long trips. So same way, if a robot, the Dax is not optimized to go 30 miles. He's got a pretty good 1.5 mile range,
Mm-hmm.
and that's a good niche to fill.
Mm-hmm. Okay. Could you imagine pairing with vehicles and things where so kind of like the package delivery idea where it'd be an
Yeah.
autonomous car that drives the robot and the robot does the last little bit of the delivery? Could you imagine Dax
Yeah.
being used in that kind of thing?
I could. It would definitely be interesting. Obviously, there's a lot of people that are working towards those types of solutions. Right?
Yeah, even
Where
in
you
the
have
Oregon
compartments.
area too. I'm
Yeah.
thinking of
Yep.
Agility Robotics, I believe, where
Yep.
they're trying to do the
Yeah,
last.
Agility Robotics, they're just up the road from us. So,
Yep. Oh, cool.
Yeah. Yeah.
The last
So,
5 meters of package delivery or whatever is their target.
Yeah. Yeah. And it's a very interesting, last mile delivery is always the most expensive. You look at logistics in general.
Mhm.
That's the hard stuff to figure out.
Yeah.
So very potentially, there's a lot more that has to go into the logistics of that, loading and unloading
a
a
lot
robot.
more moving parts. You need like a little
Yeah.
lowering platform or something to get the robot down there.
Yeah. And we've got a van that we, haul robots in, and we have that. But from a large scale, like if you're a big logistics center like Amazon or UPS or something like that, right? There's a lot of moving parts there. And
For sure.
Eventually, I could see something like that, like an Amazon locker, that drives to a town, but then every locker opens up and becomes a little robot and drives to your doorstep.
That would be super cool.
Yeah, there's probably something there, but there's a lot of not just technological hurdles to overcome, but a lot of legislative hurdles to overcome as well.
Which I do want to talk about for sure. Yeah,
Yeah.
the legislative things are very interesting. But just before we do talk about that, so you're not generating revenue yet, I believe, right?
We are now.
You're
just
starting
just
to.
in the infancy stages. Yep.
Gotcha. I'm just wondering, what will your business model be, or what is it now for generating revenue? And maybe you'll pivot around a bit, but...
Yeah. So the thing that we have right now is kind of twofold. One is that we realized kind of the back to the Dax as a celebrity thing. We can talk about it now. There's been a few events that the Dax has been in. One was for a TV show called Tacoma FD. And so there was a bunch of Dax robots that they turned into firefighters and did a bunch of promotion for a season.
Very in line with the founder.
Yeah, exactly. He was in heaven. He's like, my two worlds collided. This is amazing. And then one was for a Jack Daniels? It was some beverage company, and we did a delivery promotional event at a golf course in Napa Valley. So things like that. So different marketing agencies are reaching out to us because it's unique enough, right? It's novelty enough at this point that it's a great marketing engine for them. So so being able to do appearances and stuff has been fun, and obviously it gets our brand out there as well. So that's fun. That's been generating some revenue. The
delivery / entertainment robot. Yeah.
Right. Exactly. But those are gig events, if you will, right?
Yep.
It's not recurring revenue. So, but the actual business model is revolving around that. You have different deployments in different states that are, renting robots for, thousands of dollars a month per robot, and they're going to do delivery as a service for you, which also keeps it so that we can take care of service and those types of things. And then that's the monthly recurring model that we want to spin up. So
gotcha.
From a
so it's a subscription
from a business
where they
model
buy the hardware, or where they rent the hardware.
They rent the hardware, correct? Yep. They're renting the service of delivery, and we happen, instead of us being humans there, we have robots that do it for us.
Gotcha. So I just recently, at the time of recording this, interviewed Cobalt Robotics, and they're doing something very similar for security guard robots, where they're having the robots basically be the legs, and then they have someone controlling it at a very high level. And so to me, this is kind of similar to what you guys are doing, where you will have the robot be autonomous on the navigation, and then you'll have a person control the robot for the interaction for the delivery. Is that what you imagine?
Yeah, I'd imagine that that more and more pieces of that puzzle will get solved, autonomously. Again, like the facial recognition pieces. Are you happy, sad? How do we make your day? If you're a kid, what do we do? Those types of things. But then same with the delivery piece, being able to get to an end destination, and then somebody comes out, you realize that there's a person now in front of you. You can interact with that person, and then open your drawer if, you can see the code is correct. Those types of things can all be automatable. And that's kind of the next pieces. Gotcha.
So the goal is full autonomy as much as possible. I'm just wondering if you would have a, I don't know. So in Cobalt, they have like half of the people there are just watching over the security guards. They're the people that take over autonomy. Yeah. And I would wonder if, at least before all this stuff is automated, would you have some sort of similar model where you have a bunch of people working to do the autonomy or supplement the autonomy? Absolutely. So when it gets there, it would.
And you're exactly right. It's more of and that's what we tell people, it's semi-autonomy. Because when people think autonomy, they think full on, this robot is R2-D2 and it does exactly what I want whenever I want. Mm-hmm. But no, the semi-autonomy piece is being able to increase the number of, the ratio of operators to actual robots that they oversee, right? And the goal is to have greater and greater autonomy, which requires fewer and fewer operators that aren't necessarily interacting with every single person that they see, but making sure that robots are generally staying in line with what they need to be doing. Yeah. Or if they see something that's completely, a tree falls in the middle of their path, and now they have no way around because we're not letting it go outside the bounds of, it's on a sidewalk. It's like we can't go into the road. So an operator needs to take over and make a human decision of, okay, we're going to have to find another path, right? Turn the robot around, that kind of thing. So there will always be an overseer, somebody that's commanding, a crew of 20 or so robots. So
cool. And how did you decide to do the subscription model as opposed to like they buy the robot and they're on their own, or they buy the robot and you like manage it somehow, or they buy it and then they are a subscription thing, or like all these permutations? How did you pick the current one?
So the current one, investors really like MRR, monthly recurring revenue. They like seeing that this is going to come in whether essentially all the time.
It makes payments fairly predictable.
Exactly. And that really rings true for a lot of investors. So that's one. The second is that when people have asked us to buy the robot outright, we've kind of played with the idea, but at the same time we said, okay, well, we're going to have to come up with some sort of service contract on top of this. Because, you could take it's not ubiquitous enough where you could take a laptop to a computer repair shop and they could probably figure out what to do or diagnose it. Mm-hmm. You take a robot that nobody's seen before to a computer repair shop, they're not going to know what to do. And so at the same time, we said it doesn't make a lot of sense, because we did come up with a model and said, we can buy the robot for, I don't remember what the number was, like $30,000 or $40,000. And then it's still going to be a $5,000 or $1,000 monthly service contract to have that robot. So we said, if we have to go that model anyway. And explaining that to people, they understand that. They're like, oh yeah, because if a track falls off or, a tread wears out or whatever,
you need
is it going to be up to the restaurant to repair that? Exactly. Yeah. And so having a service model made a lot more sense. To us and to people that we've been talking to. So,
yeah, let's see. I have a few questions that I want to ask all at the same time, but one, so you're doing things where it's like they're in Atlanta, they're in California, they're in Oregon. Does it mean you're going to have to set up technicians at all of these locations so that they can do these repairs, or how do the logistics of that work?
Yeah, so it's what we do is we actually find partners in those areas that we can then train on some minor stuff. Usually it's computer repair shops or people that are in manufacturing robotics type hardware. Maybe not robotics itself, but something that they see a circuit board and they don't freak out. Then they it's not like taking it to a bicycle repair shop, right?
Yeah.
So somebody that has some experience with technology. So we partner with them, and then they become essentially our point of contact for shipping robots in and out of a city. And then we keep a hot spare that's readily available inside.
Oh, to swap. I see.
Correct. So
Just
if a
in
robot
case.
has a problem, something happens, we can within the day swap the robot out with a new robot ready to go. If it's simple enough that we can repair with remote hands, we'll have them do that on some sort of service contract. If it's more complex than that, the one that was there is a hot spare in the crate. We say, throw this one in the crate. We got another one coming your way. We ship a robot, and the robots basically meet,
Yep.
somewhere in the middle of America. So
How funny. Then the next thing, I don't know if I'm correct in this, but I imagine that food delivery is a fairly low margin industry, which means you need a lot of volume. I think this, and I don't have data, and I'm not really aware, but I don't think that the Uber Eats drivers are paid that well, or any of the delivery services. And so I think it's more about how many can you get? Does this, and I'm wondering basically for how long before the robot would pay off its existence and start being profitable to the companies and this kind of thing, if it is a low margin thing, because they have to make a lot of deliveries, probably. Yeah. This kind of thing.
Yeah, it really depends. So a good example of this would be one of the people that is getting the service down in the Atlanta area, in Fayetteville, a company called Nourish and Bloom. And they're kind of a cool new concept of a grocery store that is essentially fully autonomous.
Ooh,
there's people that can help
that
if you need
cool.
it. But yeah, so Amazon had one that was similar in Seattle, where you walk in, facial recognition, here's who I am.
Oh, so it's that kind of thing?
Okay. It's not quite that degree, but similar. And so people are coming in, they can kind of self-serve. They don't need to go check out, right? It's automated in a lot of senses. So they wanted robots as well. But if, for example, the payload isn't huge in a robot, so how do you make that valuable? And it would be similar to if you're going to shop at Walmart, for example, versus Whole Foods. The amount of money that you're going to make per bag at Whole Foods is a much higher margin than you will at Walmart, for example. Yeah, exactly. Yeah. It's a totally different market. So it's not like a luxury market that we're going after, but it is more of a high-end market that we're targeting. So the value, and
that's why you have heating and cooling and this kind of thing on your robot, so that the food arrives and is still tasty, not with DoorDash if it's slightly cold or something like this. Okay, so it's the luxury market with high.
Yes, and it's subsidized a bit to, if that makes sense. They're making higher margins on product that they're selling anyway. I mean, Whole Foods and Walmart, they don't sell exactly the same thing, but the margins are definitely different, right? So that's part of it. And then the other part is also that becomes a unique service that they can provide that nobody else does. So it would then drive more traffic from a marketing perspective. Oh, well, I can have a robot deliver it to me. These people can do that, and these people can't. So I'm going to shop here, even if it costs me a little bit more.
I know that it's cool for you guys, but I'm looking forward to the day that it's not uncommon for robots to deliver things. I think that would be sweet.
Yeah, me too, actually. Yeah,
that'd be nice. Okay, now complete non sequitur. How does your robot deal with stairs?
It doesn't.
Yes. So what? So I'm imagining, in San Francisco, it's not always the case that there are nice curbs to get around.
Yep.
So it may just be a sheer drop onto the street kind of thing. Does this? I don't know. How do you guys decide to not do stairs with the tracks, and does that affect where the robot? I'm sure it affects where the robot can go and what cities you can deploy in and things like this.
Yeah, because there's a couple of things as well. I mean, San Francisco, Seattle as well. San Francisco especially is known for some very steep streets, right? And so there's some areas that we
45 degrees in some places.
Yeah,
which
exactly.
Is just nuts.
It's ridiculous. Yeah,
they have stairs and this kind of thing.
So we wouldn't put a robot in that area just for that reason. So we had to make a couple design decisions, right? Like all engineers do. And one of those limitations is we said, okay, where can we deploy this thing? And we said anywhere that is ADA compliant. with current, if you
And
can get
that's
there in
the
a wheelchair.
American Disabilities Association?
Yeah, American
or,
Disability.
So
yeah,
a wheelchair
correct.
should be able to get around there.
Correct. So any ramp, and I don't remember what the exact slope is for that, but we said that is going to be kind of the max grade that we're gonna be on, which is still pretty steep. I think it's 18%, if I'm not mistaken. So it's still significant.
Yeah,
I mean,
somebody
in a wheelchair would be. It is a weird metric.
Just degrees. Give me degrees. So it's
Yeah,
100% is straight up, and so 18% is 20% of 90 degrees. So
yeah, I think
something like that.
So it's not nothing though, right? It's significant.
Yeah, that is really steep.
But same thing. At some point, you don't want this thing flipping over on its back, and that kind of thing. So. Stairs is something that we know we'll have to deal with eventually. Same with elevators,
especially for delivery too. Yeah, elevators. Like my apartment building, there's stairs on the way in and then elevator. So it would have to meet me outside.
Correct. Yeah, and I know that a lot of Uber Eats drivers and things like that can come to the door and
true.
A lot of them have to get rung in and you hit a code and. Usually people meet you in the lobby, something like that. So it's not completely outside the paradigm. But when we're looking at places to deploy currently, obviously we're looking for places that are more flat, that have less stairs, that are usually with upkept sidewalks. I mean, the small town that we're in is a nice little small town to live, nice place to be from, but it's a great place to test because it has terrible sidewalks. So we're finding out a lot of things about potholes and what we can and can't do, gravel, the elements getting through mud, that kind of stuff, which is obviously great for a test bed, but not an ideal deployment.
Yeah. Let's see. And we are starting to run out of time. So I would love to talk about legislation for your robot, because this is an interesting thing that I hadn't considered before you brought it up. So just tell me a bit about it in general.
Sure. Yeah. I didn't know much about it either until we started looking at deploying into different places. And the first place that had legislation for delivery robots was in Washington, D.C. And that came out in 2017. And it had different factors involved, weight, maximum speed, when it can and can't be on the roads, safety information, etc. And so different states have adapted that to very similar. Everything is fairly similar to that. Pennsylvania, for example, they said that we're going to give it the same rights as a pedestrian, minus a little bit. They do have to yield to pedestrians, and so in California and Oregon, interestingly enough, we don't have state laws regarding robots on sidewalks. So it's up to individual cities and municipalities to do that. San Francisco banned them in 2017.
You said,
and the reason
disappoints me.
Yeah. And then they made a very small exception and a bunch of hoops that had to go through it. I think Postmates is allowed to have like 2 in San Francisco now, and that's it. And the reason for that has to do with pedestrian space. People, again, the reason that DaxBot is just different. It's different than any other delivery device that's out there. So in the legislation, they call it a PDD, or a personal delivery device. So, which essentially could be whatever you want it to be. You could put a skateboard and put a motor on it and then say, drive it remotely with a camera. That's a personal delivery device, and it can drive wherever it wants on sidewalks. It can
and that's how this legislation refers to
correct
what we're referring to as a delivery robot. Okay.
Correct. Yep. And so the PDDs, and so with PDDs, we're working very hard with, I worked with the state of Maryland on their legislation, working with the state of Coronado on rules around it. And the thing is that people don't have a concept of what it could be like to have DAX. If their only experience is a remote controlled box that is getting in their way at their feet, they don't want it there. Versus DAX, which is a robot like you would see in a movie that is welcome in human space, like a dog is. And so helping change the legislation is a big deal, because there are a lot of places that it does not make sense, and it's because people don't want delivery robots on their sidewalks. But if you just look at it from that box perspective, like an engineer, like I want this box and wheels, it makes sense. It's an easy design. It's easy to do, but that is not what is being accepted. So the human acceptance piece in pedestrian space is a much bigger deal than most people realize. And that's the thing that Dax has essentially solved for that, being able to be welcomed on pedestrian spaces.
That's interesting. So it's as if part of your role in being involved with DaxBot is that you have to work with lawmakers and things to try to show them that this robot is okay in human spaces and should be allowed, and this kind of
100%. Yeah, because if this is the future that we want, namely we want robots to be able to do more things in pedestrian spaces, we have to make sure that we're not legislating our way out of existence. And not just us, I'm talking about, robotics engineers in general. If you're doing something that is public facing, most people think it's all magic, right? People that are engineers understand there's a lot of, mechanics and software and connectivity, and there's a lot behind these machines. So I guess my hope is that, other people that are out there are not doing things that would then jeopardize, urban robots for everybody else. Similar to how drones were. When drones were introduced, a lot of people did a lot of really silly things with them because it was cool technology. And now there's so many regulations around drones, and they can be very, very useful, but they're not as useful as they could be, usually because of legislation, because people did some silly things, especially in the beginning. So,
Okay. So how do you avoid doing silly things for this if you're trying to do something and you don't know it'll be silly? I assume people don't go into an endeavor going, this is going to go badly and it's going to hurt everyone because crazy regulations will be passed for this to way overcorrect and make sure this doesn't happen again.
Oh, absolutely. So
how do we avoid silly things?
Yeah, it's a good question. So like the San Francisco problem, for example, I'm sure that the engineers were like, hey, we're going to take this thing on the road and everybody's going to be in love with it.
What's the San Francisco robot problem? What do you mean?
That they're illegal in San Francisco.
Oh, yeah.
We can't take a delivery robot to San Francisco. And whoever, was a part of doing that test, the engineers, whomever, I'm sure they were thinking this is going to be amazing and everybody's going to love it. And then people didn't. And so when we go to new places, for example, usually we're finding out, what are the rules? Do you have rules around this? And then giving usually the police department a heads up. Hey, we're going to be doing this. We're going to be here. So when they get phone calls from people, hey, this robot or there's this thing in my way, or this thing hit my car, or whatever. We haven't hit
hopefully
any cars.
Not, but
yeah. There are others that have. So when they get calls, they're not completely blindsided, and then they get an angry phone call from the mayor, right? And then that's how those things happen. It's a couple decision makers that hear from some angry people in their city that can then essentially make it illegal for everybody else.
Yeah.
Yeah. So just more being aware and conscious of, where are you at, who's around, and making sure that not necessarily calling City Hall because they won't know. But if you call usually the local police department and just ask, hey, we're going to be in this area with this robot. Is there any rules around that? They'll usually be able to tell you yes or no. And you say, great, we just wanted to let you know we're in the area, give you the heads up. And so that, if it's some robot rolling along the street and people think Armageddon has happened, they can realize, no, this is this company and I've got their contact phone number, So
this is like going to, I don't know, small towns and things like this, or at least individual places, and talking to them and telling them this is what we're doing, talking to the local police department. How will it be to go bigger than there? So if it's statewide or federal or...
Sure. Yeah. When I talk local police department, Portland, Oregon isn't a small town, right? But even calling, the Portland Police Department and talking to them, whoever you have to talk to, at that level, let them know what's going on. Going from there, though, most of the regulations are actually going through the Department of Transportation. So it's finding who at the Department of Transportation needs to be aware of this if you're going to make a law. Again, the legislative process takes a long time, for laws. So I would not recommend usually people go that route first, especially if they're a smaller
But if you
player.
guys are going to keep growing kind of unfettered,
Yeah.
you would need these laws in place at a state and then maybe federal level
Correct.
for this kind of thing.
Yeah, and federally, I don't know if that will ever. It might, come about with some regulatory agency like the FAA, the Federal Aviation Administration for drones. But probably not. It'll probably stay at a state level or local level. And so the more that you can build rapport there,
by seeding it with all of the local police departments and things like this,
that you're safe,
local mayors,
and you're going to be responsible. That's the thing that I think people care about more than anything is this thing is safe and we're being responsible. And even the bigger piece of that, which obviously we don't have time talking about privacy and, things like that, data security. This isn't Big Brother spying on you, that kind of thing. But as long as people know that this thing's going to be safe.
Might make it easier to get written in. Yeah.
Yeah. But.
Okay. Yeah, that's cool. Let's see. So what is the timeline for you guys, like beginning to wrap up? What do you expect the next few years for you guys, or where are you going?
Yeah. So I expect the next couple years, 2022, the goal is really to have about 100 robots out in service in different places. We want to keep it to about 10, maybe 12 geographic locations, so by that, Los Angeles, well, there's Long Beach and there's different places. So, if we're in greater Los Angeles, how do we grow from there, from that hub? Atlanta, Georgia, how do we grow from that hub? If we go to Washington, D.C., how do we grow from that hub? And so we want to have about 10 to 12 hubs or, bigger deployments in a geographic region that we can then grow and expand from. Because that will really set the tempo for commercializing. So with the crowdfunding round, being able to build the robots that we need to deploy them into these areas. And then once we have that, essentially the operational piece has been figured out, right? There's revenue. So that it'll attract more investors, maybe higher level investors. So then we can go from that and then manufacture on a greater scale to 1,000
bring the
or
costs
2,000
down and this kind of thing.
Exactly. Yeah, bring the costs down, bring the autonomy up, because when both of those things happen, right, it makes better margins, so you can grow faster, and then be able to be more the face of robots in the same way that Tesla became kind of the face of electric cars. We think that Dax is going to be more of the face of urban robotics that does delivery, because delivery robots, again, isn't a unique example or isn't a unique idea. But the way that we're going about it is that it's cool. People want that to be in their towns and on their streets. So it's going to be readily accepted in ways that other companies probably won't be right now.
Or hopefully so, yeah.
Yeah.
Awesome. Okay. And then what have been some of the larger challenges for you guys so far, and what would you do differently to kind of get even where you are still?
Yeah. Larger challenges. One of the things, is building an operating system from the ground up.
You guys built an operating system from the ground up?
Called DaxOS, or DaxOS. DaxOS.
It's like we're at the end of the interview, and that's a very interesting thing. Okay, go ahead.
It is very interesting. The founder, great guy, and so his thing is, obviously business savvy enough to know that we can't just open up DaxOS to everybody out there in open source at this point. But that is the ultimate, I think that's his ultimate objective, is he wants to be able to open up DaxOS, which is a ROS-like software, but it's way more.
In that it does message passing and things like this, or
yeah,
and helps you with visualization, perhaps. And
yeah, it does. It does a lot of pieces, and one of the pieces that we have is as far as the firmware piece is called a Nova node. So it basically is an extensible piece of the robot. So you can plug in another Nova node. So for example, we say, okay, we need an iteration where Dax has an arm, so he can push buttons or whatever. We plug in another Nova node, and then Dax knows, oh, now I have this arm, and now I'm able to do this thing. And it's higher level intelligence, and has to do with a lot of the patents and the higher level architecture stuff. But DaxOS, that's something that is absolutely fascinating to me. My background is software, so it's really fun for me to be able to nerd out with the software guys a little bit and hear the high level architecture around it. And again, that was one of the things that the founder wants. I mean, this is the vision that he has for this could be like a future thing. So we want to make an operating system that, that is able to be open source so that other people can develop against it as well and build their own stuff, similar to like how ROS is, if that makes sense. People are familiar with the ROS, the robot operating system, but DaxOS would be similar in that vein.
So like, is it a real operating system? Because the robot operating system is not a real operating system. It's like a flavor of Linux or something, or what is your DaxOS?
Yeah, you'd be right about that. Yeah, it's more of a flavor of another one, but it's when you talk about ROS, people think, oh, operating system.
I know. Yeah, it's a common misnomer for sure.
Yeah, but so yeah, we'll put it that way. Yes. So yeah, on Linux, a lot of Linux based.
I feel like it's a very interesting idea. And one of the things that I see is kind of like, I mean, one of the things that's really nice with ROS is the whole community and all of the things that have kind of become fairly battle hardened there. If it's too big of a deviation from like Ubuntu or some of the other, I don't know, larger distributions, I feel like it would make it so that you can't reuse a lot of what exists, even like sensor packages and stuff. But you guys are clearly doing things with different sensors, so
yeah,
I don't know.
Correct. Yeah,
it's an interesting thing.
Yeah.
Is it similar enough that you can use like anything on Ubuntu, or? Oh, okay. So it's not that large of a deviation for this kind of thing. Is it real time? So is it a real time operating system?
Yes.
Cool. So it's deterministic? Yeah. That's awesome.
Yeah. It's one of the patents that...
Do you mind talking a little bit longer so we could talk a bit about this?
Sure. Yeah.
I can talk about that. You have something at the hour to run into.
I'll take off a little bit after that. But
yes.
Yeah. So the high level, one of the patents that was out there is being able to essentially have a voting system. I don't remember how it was put. Basically, democratizing decision making. So, with the Nova nodes, for example, the robot has several different ways that it can communicate. But then, how does it know which is the most important thing to do? So, for example, you say, "Hey, robot, you need to take this package and deliver it to this destination." Robot then goes down that road and says, "Oh, there's a tree in the way. This vote is telling me that I need to go that way. What do the other votes say?" And being able to then analyze what are all the other factors going on. What is the next thing that we do? And so that is I'm really
like a behavior tree, but like it sounds like so you could have a state machine or something, but it sounds then that could be represented as a behavior tree.
But a lot more.
You have more logic kind of baked into it.
Right.
Okay.
Yeah, a lot more exactly, and a lot more real time type logic. Like what is going on right now as the environment is changing, because the environment is changing all the time. Like, do I stop and so a better example would be like, okay, I'm supposed to deliver this package, but I see this 6-year-old girl coming towards me. Do I stop and talk to the girl? Based on what? Based on, I've got time. Okay,
yeah,
that would vote. Okay, we're going to vote that we're going to stop for 30 seconds and say hi to this girl, versus just blowing past because I've got something to do. But sometimes it could be, no, this is a higher vote because you need to get to this destination by this period. And, so that is a big piece of, kind of the patent behind it, is being able to have a voting system that's intelligent enough to know what to do next.
Interesting. Yeah, the voting system, like you could figure out several ways of scheduling what would be important. It could be probabilistic. It could be a integer voting system count. It could be real numbers or whatever it might be.
Yeah.
And then it sounds like it sounds like you have more of a behavior tree setup where it's like, I'll choose this or this or this based on different options that are available. And that's very baked into this kind of conditional logic of what to do. Mm-hmm. So maybe it has a nice representation of how to encode these kinds of behaviors or something. Is that so? It has a nice way for programmers to define what it is that should be considered in making decisions or how to prioritize.
Yes. Yeah. Yes, I'm sure that Wilkins, who's our he worked at Tesla for a while, and I'm sure he would be shaking his head and saying, "Jason, you're totally butchering it."
Well,
he was kind of one of the main architects of it. But anyway.
So with that, I notice right now you don't have very much on the company GitHub website.
Yeah.
It would be very nice if this that you're talking about would be open source so that it can be poked around and we can look at it and this kind of thing, because that would be very cool. What is on there is mostly JavaScript, which is interesting to me. Could you tell me a little bit about the decision? I don't know if like your operating system, a lot of the code that you're running is running in like a Node.js framework, which is like a, what is it, server-side JavaScript framework.
Yeah. We do a lot. We do a lot in Node.js. So.
Gotcha.
Yeah.
Interesting. So it's going to be like a Node.js ROS-like thing that has behavior trees. Would that be a way to think of? What did you call it again?
We call it Dax. So DaxOS, just like the robot.
DaxOS. Okay.
Yeah.
Gotcha. Cool.
Yeah.
Any timeline on open sourcing that? Because it'd be cool to poke around.
No, I don't have a timeline, and unfortunately, right, you have to weigh, the business decisions versus, at some point, similar with patents. Anybody that has dealt with patents or litigation around that, patents aren't necessarily the end all. It's not like, hey, we invented this thing and nobody. It's actually more of a defensive mechanism. So if a company decided that they wanted to file a lawsuit with us and say, hey, we have this patent on this thing, and it's really we have a patent too, so this is why we're allowed to operate in this space. So that is, from a business standpoint, that's the reason that patents exist. But the other piece of it too, obviously, is protecting intellectual property. I get that. But in the same way, like, writing, source code and things like that, if you let out too much of the secret sauce when you're in like infancy type stages, like this, it could put you out of business. It's not super likely, that somebody would take and be like, oh, we're going to do exactly what Dax did. But the founder, that's definitely one of the things that he absolutely loves is, wanting to make this open source. So I don't know what the dollar amount is or the comfort level is to the point where he's going to want to open this up to the world. But that's something that he talks about pretty regularly, wanting to get there.
Well, that'd be really cool. It would probably be a good way to battle harden it too.
Absolutely.
Like you guys are running it, and so you said you currently have about 10 robots. By the time you have 1,000 robots or something like this, it'll probably, like, the software is going to get a lot more battle hardened because you'll just have run it through so many things, but the community probably could help in that process.
Oh yeah, absolutely.
Like, it's amazing to me, some of the things, like, I mean, so I guess, I don't know what's public that I can say, but there's a lot of very, I would not expect open source to be used in a lot of really critical projects that are done by companies that have a lot of stake and reliability. And I'm very impressed that a lot of open source software is being used there. So it does battle harden. And so it might be a benefit for that reason. And then also people would have a better point of comparison to look at it and see if it's useful and this kind of thing. And that would be awesome.
Yeah, absolutely.
Okay, so now we are going a little over time. What do you, I guess, wrapping up, any links or contact info or anything you'd like to share with our listeners?
Sure. Yeah, I think that, again, those that are listening just via audio, can't see the robot behind me. So if you go to DaxBot.com, that's DaxBot.com. That's, you can see kind
and
of the
we'll
robot.
Put links with the episode so that they can just click if they look in the description.
Yeah. And then those of you that are so inclined, startengine.com/DaxBot is where we're doing our crowdfunding raise. And you can take a look at kind of the more the business plan around it, kind of the need and the focus that we're filling and all the legal stuff we filed with the Securities and Exchange Commission. So anyway, those would be the two things, DaxBot.com and then startengine/DaxBot. And yeah, appreciate that.
All right, awesome. Been great interviewing you.
Yeah, you too. Thanks so much, Audrow.
Thanks for listening to this conversation with Jason Richards. Thank you again to our founding sponsor, Open Robotics, and I hope to see you next time.